Order of operations. What does it mean? Sometimes we hear PEMDAS. Sometimes we hear the mnemonic device, please excuse my dear Aunt Sally. I don't have a dear Aunt Sally, so I don't know who they're talking about, where it stands for, respectively, parentheses, exponents, multiply, divide, add, and subtract. Sometimes we hear other things like, pudgy elves may demand a snack. Or if you like movies and donuts, maybe you say, popcorn every Monday, donuts always Sunday. Or if maybe your mom likes to bake, it's please eat mom's delicious apple strudels. Or how about people everywhere made decisions about sums? Maybe that one makes the most sense when we think about the order of operations. Or how about you're from the UK? You might have seen it as BODMAS, which stands for brackets, orders, divide, multiply, add, and subtract. Or perhaps you're from Canada. How about that? Maybe you're from the Great White North, where instead of BODMAS in the UK, now it's BEDMAS, where it stands for brackets, exponents, divide, multiply, add, and subtract. But these are really all just mnemonic devices to remember the order of operations. So let's consider an example. How about 2 plus 5 times by 3? Well, is it 7 times by 3 equals 21? Or is it 2 plus 15 equals 17? Which one is it? When I think about multiplication, something like a times b, I always think of an area model, where a times b is the shaded area. But you could also think of incremental a's added b times. How about 2 times 3? Well, we know that that's 2 plus 2 plus 2, or 3 plus 3. So either way, it's repeated addition. When we consider exponents, like a to the b, where a is the base and b is the exponent, we know that we can write that as a times a, b times. Or, if we consider a specific case, we consider something like 4 squared, which is actually 4 times 4, or 4 plus 4 plus 4 plus 4, again, being repeated addition. So if we can consider subtraction, isn't subtraction really addition in disguise? Well, let's look at an example 4 minus 3 equals 1. Well, isn't that the same as 4 plus negative 3 equals 1? So really, it's all addition. Returning to our example from earlier, 2 plus 5 times by 3, when we were trying to decide between 7 times by 3 and 2 plus 15, we now see that multiplication is repeated addition. So the answer is 2 plus 5 plus 5 plus 5, which is 17. But how did I know? Well, the order of operations. Let's consider a slightly more complicated example. 2 plus 1 plus 2 quantity cubed minus 7 times 4. So we can rewrite that from what we learned earlier about exponents and bases as 2 times by parentheses 1 plus 2 parentheses 1 plus 2 parentheses 1 plus 2 minus 7 times by 4. Simplifying the second parentheses to 3 and knowing that multiplication is simply repeated addition, we can expand the equation to 2 plus 1 plus 2 plus 1 plus 2 plus 1 plus 2. Again, doing the same thing for the third parenthesis in the second line, we can distribute that. So now we'll have 3 sets of 1 plus 2, 1 plus 2, 1 plus 2. Or we'll have 9 total parentheses of 1 plus 2. As you can see, when we expand the equation, it gets quite large, but the math is very simple. So as I continue to write out the equation, we then have negative 7 repeated addition 4 times. So negative 7 plus negative 7 plus negative 7 plus negative 7. Expanding out the equation, we can see that all those quantities are actually 3, and we have 9 of them. So we have 2 plus 3, 9 times, minus plus a negative 7, plus a negative 7, plus a negative 7. And we can see that this simplifies down to 27, 28. So we get 2 plus 27 minus 28, or the solution, which is 1. So we can see that it all expands. So it all comes back to addition. where exponents are multiplication of a base to the exponent that many times, where multiplication is really repeated addition, as we saw. And also, subtraction is the addition of a negative number, or an additive inverse. In closing, addition is the fundamental operation of arithmetic upon which all other operations are based.